Hello, everyone. I'm here to help you analyze your results from your Operon lab. So go ahead and make sure before you continue that you have your lab guidelines with you. You should have the qualitative procedure and quantitative procedure, but we're following the quantitative procedure just as a review. That's what we did in the lab. We did the quantitative procedure. Okay, so just to recap a little bit, we did this lab last Friday, if you recall, and there is a video. If you were absent that day, there's a video that you can go check out. I put it on Google Classroom where it's me explaining how to do the lab, and then I put it with one of the groups in the 4th and 5th hour class so you could see how the lab was actually done step by step. They did a great job of going through each procedural step and what they were doing. So thank you guys if you were that lab group. Okay, so you should have, here's what you should have filled out. You should have your qualitative lab table. I had you fill out this table, okay? Even though we didn't do the qualitative procedure, I still wanted you to have that table filled out because you were going to record the description of what it looked like, so we could see if there was any color change, which after about 30 minutes, you should have seen a slight color change in at least one of the tubes. If you don't have that, reach out to your lab group members and see if one of them has that qualitative table filled out if you had just one person in your lab recording the data. You will also need your quantitative table. You'll need all the data from that to do this. If you were in 2nd or 3rd hour, then that means that you only got to 30 minutes. But if you were in the 4th and 5th hour class, I believe every group got to 40 minutes. So depending on how far you guys got, one of you guys may be missing that time component. If you were in the 3rd and 4th hour class, you didn't get to 40 minutes, so you can disregard that. But if you were in the 4th and 5th hour class, you did get to 40 minutes. So that means for the 5th hour class, should be filled up to that 40-minute time slot, and 2nd and 3rd, you should have up to that 30-minute time slot. And again, go ahead and reach out to your group members if you don't know who had, if not everyone recorded the data at the same time. Make sure you have all your data before you continue watching this video. Okay, so let's first go to where the description is of the Miller units, which I have to flip through my book to find it. Okay, so it should be on page S6. So turn to S6, which is the quantitative procedure. And here you can find the equation for Miller units. And it gives a description of what every aspect of that equation is. Okay, so you have your 1,000 times A420. We did that measurement. Minus 1.75 times A550. We took that measurement. Over time, multiplied by volume, multiplied by A600, which we took that measurement at the very beginning for each tube. Okay, so I suggest you have your maybe this video going while you have the spreadsheet that I uploaded to the Operon assignment on Google Classroom. Go to that spreadsheet. That's what I have going right here, okay? You'll need to make a copy of that so that you can change all of this that's going on here. You can change it to fit your data that you collected. Okay, so here I just have some example data. This was from, I believe, the 2016 lab that one of the classes did. So I've been doing this lab for a bit. And what you're going to do first is see all this information right here. Okay, all of that right there, you're going to input your own data there. Okay, so you don't need to change these headings. You can keep them. That's glucose absorbance at 420, glucose absorbance at 550. Then you have lactose absorbance at 420, 550. Then you have glucose and lactose absorbance at 420 and 550. Okay. Time at 0 should be 0. okay? But this is what you'll need to change. You'll need to change this part to fit your data. So you go to your table and you import those numbers in. So for example, 10 minutes, you have your A420, and that is for your glucose group. You will put that right here. Okay, so you find the time component, you find the A420, you put that number there instead. So you just take out the 0.672 that I have and put in your own number. Do the same thing for glucose 550. Go through each of these groups and change those numbers. Make sure they're accurate. Make sure that you're putting in the right number in the right spot. But you are changing all of these numbers to fit your data. And again, if you didn't get to 40 minutes, you won't do this last row. Okay, but if you did, you will need to change all of this. Okay, so that's the first thing you should do is change that data. I would pause it, completely pause this video, and go ahead and do that data, change that data now. Okay, so now if you've imported that data, so I'm going to assume you put your own numbers in for this part, that will change the numbers automatically on this side. So that's what you're going to notice if you make a copy and you change these numbers, that these numbers are going to change. Because I've already set up the equation for Miller units for you here. So by changing the numbers on this side, what you're doing is you're changing what the equation output is. So I want you to go on glucose at 10 and just click on it twice, and you'll see this whole equation. You can see it right here where the cell is, and you can see it right here. By cell, I mean Excel, like the individual box is called a cell. And you'll also see the equation here. It's easier to change things up here in this little FX region. So you should see your numbers. You should see F4. So you'll see in the glucose at 10 minutes, F4 is referring to A420, which is where it should be. If you remember back to the Miller units equation, you can go back and double check these. That's what I recommend. Make sure it's set up correctly. But you have, in this equation, I have the 1,000, and then I have multiplied by F, and then I have the numerator F4, which is that 420, which is just what it is on that Miller unit spreadsheet, or Miller unit equation, minus 1.75 times G4, which is that A550, and it highlights these regions in the corresponding colors, which makes it easy for you to know which number that is referring to, which cell that is referring to. So G4, it's purple, so it refers to this purple box here as glucose A550, and that's where it should be in the equation. Then you have double parentheses, so we're closing off that numerator and then going to the denominator. And here's where we have to change something else. Okay, so you have your parentheses A4. Okay, A4, which is that teal box, is time, and that's where it is on your equation too, is time. The time is 10 minutes, so the time will just be 10 for that, but you can just, it's just adding this 10 from this cell here and subbing that in right there. So this means basically for this time component 10 times, and then it has the next number, 4.4. That should be your total volume in each tube. Where I got that number from, 4.4 is just the total volume. You added 2 milliliters of your E. coli to each of those tubes, those OMPG tubes that we measured, and then you took 2.4 and 2.4 milliliters of the ONPG. So you add 2 to 2.4, and that's how you get the 4.4 total volume in that cuvette that you were measuring for each of your OMPG tubes. So the 4.4 is the total volume, which is found in this next, the next unit here on this equation. So we have time. You don't need to change time. I set it up for you. You don't need to change that. 4.4, that is the case for each of your tubes, so you do not need to change that either. 4.4 is correct. Don't need to change that at all. The last part is what you need to change, which is the A600, okay? I have in here 0, 0.948. So for that group back in 2016, that was their A600 for their glucose tube. You took your own measurements of A600 for your glucose tube. So all you will need to do is go in and sub out this number for your A600. Don't forget to do that. Okay, so you can just take that and say you had 0.997. Okay, that's your measurement. Okay, so then you just hit enter, and then if you go back there, you can see it's still changed. Okay, so I changed that number, and it will change the output number there too. Okay, so you will need to change that for this one. So you can see for your lactose tube, you'll need to change out the A600 there, just here. That's the only thing you need to change out. Everything else is fine. And then you have to change out your glucose and lactose A600, which is right here. Same thing as right there. Make sure you change the A600 value on the denominator. That's the only thing you need to change on this side. Okay, so, and if you need to get out of there, out of the equation, just hit escape. That's the easiest way to get out of there. Okay, so once you change the A600 for each of these, the glucose, the lactose, the glucose, and lactose, you'll need to go and change it for each time component, okay? You're going to need to change each of these out. For here, change each one to your A600. Your A600 should be the same for each glucose tube. So all of these will have the same A600 value. All of these will have the same A600 value. All of these will have the same A600 value, okay? Because you only took one A600 measurement for glucose. You took another one for lactose. Took another one for glucose and lactose. Only 3 A600 measurements, but you have to make sure you change it for all the time components. But don't change anything else over here because I've set the whole equation up for you. Okay, so to recap, you need to change out these numbers here, these numbers right here, to fit your own numbers. Double check to make sure they are correct. Double check with your group to make sure you have all set that up correct, because you should all be the same. Then you come over here and you need to change only your A600 values, which is just this very last number right here. For each of these cells, you need to change it for each of those cells to fit your A600. Then you will have, after you're done with that, you're going to have the correct equation for Miller units. So this should all be correct. Once you've made those changes, that will all be correct. Okay, now let's talk about how to graph this. So how to graph. Okay, so you may be wondering what exactly you're graphing here, which is a valid question. You should not be graphing this section. This section was used just to calculate this equation. Now, why do we calculate this equation? This equation, this Miller units, and it describes this in your procedure, so you can read this for yourself, quantitative procedure. But the Miller units is basically a measurement of beta-galactosidase activity. Okay, so this was measured by, this equation was come up with a scientist named Miller who specifically studied this enzyme's activity. So we are using this equation from the scientist who found that this was a way to measure beta-galactosidase, which if you recall from our Operon, the beta-galactosidase is what breaks apart the lactose. Remember, lactose is that disaccharide made up of 2 units. The beta-galactosidase, also called lactase sometimes, but it breaks apart that disaccharide in 2 monosaccharides. Okay, so we're measuring the activity of that enzyme breaking up the lactose into 2 disaccharides. And why is this a measurement of the Operon? I know we haven't been in school for a while, so just to review it for you, The prokaryote, E. coli, which is bacteria, which is a prokaryote, they will only make beta-galactosidase because it's part of the operon only in the presence of lactose when there is no glucose. So ideally, what you're going to see in your graph is you're going to see a high level of activity in the lactose group, and you're going to see a low level of activity in the other two tubes, meaning the glucose and lactose, because glucose is favored over lactose, and the operon will not make beta-galactosidase if there is glucose available. And you're obviously going to see very low activity in the glucose group, which is the best measurement of a control. It's most like the control in this, because if there is no lactose available, there should be no beta-galactosidase activity because there is no beta-galactosidase being made and there's no lactose to break it up. Okay, so what you should see ideally is a high level of beta-galactosidase activity. So those numbers should be highest in your lactose group, which you probably could have predicted. You probably predicted in your hypothesis when we went over the pre-lab questions. Now let's go over how to graph it. Just to review, it's been a while. Okay, so going back to the sheet, it's already set up for you, easy peasy. So you're just going to highlight all the relevant data, which is the calculation. You're graphing the Miller units, okay? So highlight this entire set of columns and rows, include the time, include the glucose and glucose lactose, because that way you're going to get those, you're going to get that in your setup in your key for your chart automatically. So then you have, once you have that highlighted, go to insert, then go to chart. Okay, so it pops up right away like this. You already have time in minutes, which is great. So that label's already there. You have your glucose, lactose, and glucose, lactose. And that's why you highlighted those sections to begin with, so you could get those labels right there. So this group did a good job back in 2016. They had lactose was their highest activity, and it did fade over time. That is probably the case because it's utilizing a lot of the lactose. But yours may not fade over time, but you should see if there was no error present in the experiment, what you should see is a high level of lactose activity, which makes sense. It's probably what you predicted. It's what your hypothesis is probably what you hypothesized in your experiment. So now what you'll need to do, you'll need to change the title. So remember to come, I'll move myself over here. Oop. I'm over here now. So change this to beta-galactosidase activity in various environments. That would be a good title, because that's literally what this is measuring. You will need a y-axis title. Don't forget to do that. So you have to choose, this was chart title. If you want to change your y-axis title, it's your vertical axis title. So make sure you highlight that this is in Miller units, okay? So this is beta-galactosidase activity. Spelled that wrong. Activity. And then put Miller units, because that's what our unit is for this. Okay, so now you've labeled your y-axis. Your x-axis should be labeled, but just in case it doesn't, you would go to the horizontal axis title and you can change that. If you really like me as a teacher and you don't want me to go crazy, you could always get rid of those disgusting grid lines, but I won't make a fuss over that. But they are disgusting. Disgusting. I got rid of that, my axis in time. Okay, we don't want to do that. But anyway, make sure that you do, there we go, I just put it back. Make sure that you add data points. If you don't remember to add data points, you go to series, and then you go to point size. Right here, it says none. So just make sure you add those data points in, because that you will have points taken off of your lab report if you don't have data points. It's in the rubric. And then, just double checking, then it does look good. Okay, so this graph looks complete. Again, you can get rid of those disgusting grid lines if you would like to mess with that. I'm not going to in this video, but this is how you do analyze your results for the LAC Operon lab. Come to me if you have any questions over any of this. Have a great snow day. Bye.